Hello there, and welcome back to the last module in this course. We are talking about probability, so if you turn to that last section of your notebook, we will look at some probability basics in this video. And the first thing I want to do is to give you some definitions of these terms that we will use over and over. And the first one is experiment. Experiment. An experiment is an activity or situation in which the result is uncertain. And you've probably heard this word before, experiment. Scientists do experiments all the time. It's an activity or situation in which the results are uncertain. An outcome is the result of an experimental trial. And I'm going to wait on tree diagram, I'm going to wait on that one for just a minute. And let's focus on experiment and outcome for just a second. So let's suppose that I'm going to do an experiment where I take a number cube or a die. Dice is plural. So if you're saying the word dice, you're talking about more than one of these number cubes. But I'm going to roll the die and I'm going to do an experiment on that. So the experiment is going to be maybe 10 rolls of the die. Okay. So I'm going to do a test. I have no idea how this will turn out. It is just an experiment to see how this data will unfold. And I'm just making this up. If I were really serious about this, I would have brought the die with me and I would have rolled it and we would see what it is. But it's okay. You get the gist of what we're doing here. So I'm going to create an outcome table. And let me show you how to do that in case you ever have to do that. You just draw yourself a table. 8, 9, 10, because I'm going to have 10 trials. So this side is called the trial or the test, and this side is called the outcome. So for this experiment, I'm going to roll the die 10 times. So I'm going to do 10 trials in this experiment. So those are my rolls. This is the roll in this case. If I were flipping coins, that would be the flips. If I were drawing marbles out of a bag, that would be drawing. So whatever you're doing is the trial. So let's say on the first roll, I roll a 3. So I roll this one on the first roll. On the second roll, I roll a 5. So on the second roll, it's going to be this one. On the third roll, I roll another 3. Then a 2, a 1, a 6, a 5, a 5, a 5, and a 4. And I just made those up at random. So the trials are on the left. Those are my rolls. And then the outcome is what I rolled. So you can see that the 5, oops, sorry. And then the 3, I got this, and this may be making you think of mode. How many? The 5 is the mode. There were more of those than the others. So here's the 2. I rolled it once. The 1, did it once. And the 4, I'm sorry, the 6, did it once. And then the 4, I don't have another color, so I'll just have to leave it blank. But all I'm doing is matching up the outcome, in other words, what did the die show, and the trial that I did. Okay, so it's pretty straightforward right here. We're just talking about an experiment, in this case of die rolling 10 times. Okay, let's look at a tree diagram, and let me give you the definition of that first, and then I'll show you how to make one of these. A tree diagram is a branching diagram that shows possible outcomes of an experiment. So we're still dealing with experiments and outcomes and all that good stuff, but we're looking at this in a specific kind of diagram. So here's the experiment. This time we're not using a die. This time I'm going to flip a coin 3 times. And I want you to think about what a coin looks like, heads and tails. So if you look at a coin, a dime or a penny or whatever it is, doesn't matter, because all of coins in America have heads and tails. So it's not going to matter. Hold on. I'm trying to get a duplicate so I can show you. Okay. And my PC is not wanting to cooperate. I don't know what he's doing here. Okay. So on one side of the coin you have the president's face. That's called the heads. And on the back of the coin you have the picture of the building. So that is the tails. And it doesn't matter, again, which coin you're flipping. If you're doing dimes, quarters, you've got heads and tails. So on a coin, if you flip a coin, there are 2 possible outcomes. You can either get heads or tails. So there are 2 possible outcomes on each flip. Okay, so what we're going to do is build a tree diagram to show how this works. So I want you to picture in your mind that I am flipping the coin the first time. And remember, we're going to flip how many? 3. So the first flip, what could happen on my first flip? I could either get heads or tails. And you may be thinking, why is she writing so much space? But you'll see. So there's one flip. Okay, on the second flip, I could either get heads or tails. But this is going to depend on what I got the first time. Okay, so if I got heads the first time, the second time could be another heads, or it could be a tails. But if I got tails the first time, then I would need to do that also down here. So I already have 4 different possibilities that could have occurred at my second flip of the coin. So I've flipped once and twice, and so far I have 4 different possibilities. So look what happens when I flip the third time. Oops. Let's use a different color that we can see a little better. How about orange? So the third flip, okay, we could have had heads or tails, assuming this was the first option. So here's this one, and here's this one. And if I had had heads, tails, then I could get heads or tails again. So here, and you can see the tree diagram starting to form. And I've got a little too much space, but I'll fix it. And then heads or tails here. And I'll show you how to read this diagram too. We'll build a table to fix that. So this is called a tree diagram. It's showing me all the possibilities for this experiment, for flipping the coin 3 times. So let's go ahead and construct another table over here. And again, I left this so that you could help me draw it. 6, 7, 8, 9, 10. I need 10 lines down. 5. I think that's right. Let me try again. I didn't get it straight. 6, 8, 10. And let's go over here and then 10 lines again. So we're building a table. This is good practice, even though it's tedious. I know it's tedious, but so we're going to make that one. Mark off your rows. These will be our different options. And you'll see when I get started, I think, how this information will fit in the table. So let's draw a divider there. It doesn't have to be exact, just get it close. Okay, so the title of this table is Coin Toss, or Coin Toss Experiment. And first, this is the first toss, the second toss, and the third toss. Okay. So let's follow this first branch of the tree. So the first flip I got heads, second flip heads, third flip heads. So I'm going to say H for the first, H for the second, H for the third. And then I have first coin is H, second is tails, third is, I'm sorry, I skipped one. Let's try that again. The first one is heads, second one is heads, third is tails. So heads, heads, tails. Then here I have first one is heads, tails, heads, so HTH. And then, sorry, hit the wrong one, HTT. Okay, so these are all the yellow possibilities. If I follow those branches, those are my options. So let me use blue on this second one. So I could have the first one T, second one H, third one H. So T, tails, H, H. Or I could have T, H, T. Or I could have T, T, H, tails, tails, heads, or TTT, all tails. So this would be the second part of the tree, where the first coin was tails. And you might be thinking, oh my goodness, am I going to have to draw this on my test? And the answer is no, you will not have to draw on your test. What I want you to be able to do is read the diagram. If they give you one of these to read, then you will have seen it before and know how to read it. And I know it's complicated. This is one of the more difficult things to think about. And you can imagine if you flipped that coin 100 times, what that tree would look like. This is the tree with 3 flips. So if you were to flip 100 times, it would be more than we could follow. So these are usually going to be with 1, 2, or 3 trials in your experiment. They usually don't get very big after that. So this is just an example. It's nothing to fret about. I just wanted you to have seen it before. Okay, in the next video, I'm going to go ahead and stop this one. We'll look at some more definitions, and I'll show you how to calculate a permutation. So I will see you soon.